When we find a result and we round it, then there is a difference between the rounded result and the exact result, and this is called a rounding error. We distinguish between two types of rounding errors, the absolute and the relative rounding error. The absolute rounding error is just the difference between the two results, and since we're not interested in which one is larger and which one is smaller, we just take the modulus of this difference. The relative rounding error tells us by how many percent we are wrong when we're rounding the result. So we take the absolute rounding error and divide it by the exact result, which means that we take the exact result minus the rounded result, the modulus thereof, divided by the exact result. Now let's look at example 1. In example 1, we're given the exact results, so in A 24.1, in B 11.4, and in C 10.6. And then we round them to the next integer, so in A we get 24. And now we have to find the absolute rounding error committed and the relative rounding error. Do that on your own for A, B, and C. Stop the film, and here comes the result. Note that in B and C we have the same rounded result, 11, and we have the same absolute rounding error, namely 0.4, but the relative rounding error is different, 3.5% versus 3.8%, because the relative rounding error is defined in dependence of the exact value, which here is 11.4, while here it's 10.6. In the next examples now, we will round exponents. So here we have 10 to the power of 4.01, and we round it to 10.4. Here you see 10 to the power of 4.9 to 10 to the power of 5. So let us look now at example 2, and again find absolute and relative rounding error. Do that on your own, stop the film, and here comes the result. We get an absolute rounding error of 233 and a relative rounding error of 2.3%. Now in example 3, we round this 3.6 times 10 to the power of 4.9 to 3.6 times 10 to the power of 5, so a very small rounding. Well, let's see what this means really as absolute and relative rounding errors. Solve it by your own, stop the film, and here comes the result. And we see the absolute error is 74,000, and especially we see suddenly the relative rounding error is 26%. So that's much more probably than anybody of you would have expected when rounding just 4.9 to the 5. Let's look now at example 4, where we round 10 to the power of 51.3 to 10 to the power of 51. So again, just rounding 51.3 to 51 seems to be a very small rounding error. Solve it by your own, find the absolute and relative rounding error, stop the film, and here comes the result. We get an enormously large absolute rounding error, 9.95 times 10 to the power of 50, and relative rounding error is 50% of the exact result. So the main takeaway here is always be very careful when rounding exponents.